Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It is useful for recalling when exam coming man student. Just selected, blank. Based on G scheme for Electronics Engineering Group. Subject, Mechatronics, 17,660. These are mostly important questions which is always repeat, form top. To end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter. Download link is below. Just close eyes and listen.
One. Enlist any 8 applications of robot ANS. Any 8 correct applications 1/2 mark each. Automobile industry. Assembly of care engines, car wheel mounting system, electronic industry, microcircuit assembly and surface mounting. Nuclear industry and hazardous environments, fuel handling in nuclear reactors, inspection in nuclear power plants. Material handling, packaging system, to load and unload industrial workpiece. Welding, spot welding, arc welding, assembly, machining, spray coating. Die casting, coal mining. 2. How robots are classified on the basis of workplace. Give one example of each robot. ANS, classification 1/2 mark each. Application, any one, for each robot 1/2 mark each. Classification of robot. Material processing robot, material handling robot, assembly robot, inspection robot. 3. What is MEMS? Explain with neat block diagram. ANS, definition 1 mark, block diagram 3 marks, explanation 2 marks, definition of MEMS. MEMS are mechatronic systems that consist of mechanical elements and electronic circuits. A micro-electromechanical system is an integration of mechanical elements, sensors, actuators, and electronics on a common silicon substrate through microfabrication technology. Block diagram. Fig. Block diagram of MFMS. Fig. Block diagram of MEMS. Explanation. Input signals. These are the signals admitted to the MEMS package from various sources or systems such as electrical, mechanical, chemical, optical, and so on. MEMS package. It is a semiconductor chip which can be fabricated by suitable micromachining technique. It consists of microsensor, microactuators, and a signal transduction unit. Signal transduction unit. This unit is provided for conditioning the generated signals. The transduction processes includes amplification, filtration, and signal conversion. Output signals. These are the signals interfaced with the system to be controlled or monitored. Due to monolithic integration of sensors, actuators, and signal transduction unit, closed-loop control system can be easily developed. 4. Explain how MEMS accelerometer is used as airbag sensor for car system. ANS. Diagram 2 mark, explanation 2 mark, related explanation should be given marks. MEMS accelerometer is used as airbag sensor. Mechanical ignition airbags fit inside the steering wheel pad. When a collision occurs, the inertial sensor moves, setting off a mechanical igniter and inflator to deploy the airbag. As the sensor and igniter were in the same unit, the compact airbag unit easily fit most steering wheels, allowing broad application of the airbag unit. With electrical ignition airbags, a computer monitors signals from the impact sensor. When it detects a collision, the computer sets off the airbag's igniter electrically. Therefore, the sensor need not be close to the airbag, but can be placed anywhere on the vehicle and connected to the airbag with wiring. This is especially effective when fitting both driver and passenger side airbags. 5. What is degree of freedom? List the function of end effector. ANS, definition of DOF 2 marks, function of end effectors 2 marks, diagram can be optional. DOF, degree of freedom, is a term used to describe a robot's freedom of motion in three-dimensional spaces, specifically the ability to move forward and backward, up and down, left and right. For each DOF a joint is required. Fig. Degree of freedom, DOF. End effectors. End effector is the device at the end of a robotic arm designed to interact with the environment. End effectors originates from robotic manipulators, robotic arm. It is the last link of the robot. End effectors. It is a device at the end of robotic arm, designated to interact with the work environment. It is a last link of the robot. It is similar to human hand with or without finger. It incorporates various sensor. 6. Explain in brief Cartesian robot. ANS, diagram 2 marks, explanation 2 marks, explanation. A Cartesian coordinate robot, also called linear robot, is an industrial robot whose three principal axes of control are linear, i.e. they move in a straight line rather than rotate, and are at right angles to each other. The three sliding joints correspond to moving the wrist up down, in out, back forth. Among other advantages, this mechanical arrangement simplifies the robot control arm solution. Cartesian coordinate robots with the horizontal member supported at both ends are sometimes called gantry robots. They are often quite large. A popular application for this type of robot is a computer numerical control machine, CNC machine, and 3D printing. The simplest application is used in milling and drawing machines, where a pen or router translates across an XY plane, while a tool is raised and lowered onto a surface to create a precise design. Diagram. Cartesian robot. Or 7. Draw the block diagram of robot system. Explain the role of sensor in robot system. ANS, block diagram 3 marks, role of sensor 1 marks. Or block diagram of robot system. Or uses of sensors in robotics. The sensors are one of the useful technologies which play a vital role in the robotics field. There are 4 important categories where uses of sensors are highly required in robotics, such as safety monitoring, interlocking in work cell control, quality control in work, part inspection, data collection of objects in the robot work cell. 8. Explain in brief spherical robot. Why it is called a spherical robot. ANS. Explanation. 2 MKS. This is also known as a polar coordinate robot. This robot positions the wrist through 2 rotations and 1 linear actuations. As shown in above figure, the orientation of the tool plate is achieved through 3 rotations in the wrist with toe of A, pitch of B, and yaw of C. The robot is easy to control. For a given maximum reach of the robot, the work envelope is smaller than that of cylindrical robot. Spherical robot can be moved in any circular movement, so called a spherical robot. A spherical robot is a robot with 2 rotary joints and 1 prismatic joint. In other words, 2 rotary axes and 1 linear axis. Spherical robots have an arm which forms a spherical coordinate system. 1 MKS. 9. How MEMS accelerometer is used as airbag sensors for car safety. Describe in brief. ANS, diagram 2 mark, explanation 2 mark. MEMS accelerometer is used as airbag sensor. Explanation. Mechanical ignition airbags fit inside the steering wheel pad. When a collision occurs, the inertial sensor moves, setting off a mechanical igniter and inflator to deploy the airbag. As the sensor and igniter were in the same unit, the compact airbag unit easily fit most steering wheels, allowing broad application of the airbag unit. With electrical ignition airbags, a computer monitors signals from the impact sensor. When it detects a collision, the computer sets off the airbag's igniter electrically. Therefore, the sensor need not be close to the airbag, but can be placed anywhere on the vehicle and connected to the airbag with wiring. This is especially effective when fitting both driver and passenger side airbags. 10. State the function of manipulator and end effector. For MEMS, function of manipulator, manipulato arm, and body. The arm and body of a robot are used to move and position parts, or are, two marked tools within a work envelope. They are formed from three joints connected by large and end links. Effector, to wrist. The wrist is used to orient the parts, or tools at the work location. It consists of 2 or 3 compact joints. Functions of an end effector. 1. End effector is the device at the end of a robotic arm designed to interact with the environment. 2. End effectors originates from robotic manipulators, robotic arm. It is the last link of the robot. 3. It is the last link of the robot. It is similar to human hand with or without finger. It incorporates various sensors. 11. Explain the function of PLC. Draw a block diagram of basic PLC configuration. ANS. Programmable Logic Controller, PLC, or Programmable Controller is an industrial digital computer, which has been ruggedized and adapted for the control of manufacturing processes, such as assembly lines, or robotic devices, or any activity that requires high reliability control and ease of programming and process fault diagnosis. 1. The functionality of the PLC has evolved over the years to include sequential relay control, motion control, process control, distributed control systems, and networking. 2. The data handling, storage, processing power, and communication capabilities of some modern PLCs are approximately equivalent to desktop computers. 3. PLC-like programming combined with remote I/O hardware allow a general-purpose desktop computer to overlap some PLCs in certain applications. Desktop computer controllers have not been generally accepted in heavy industry because the desktop computers run on less stable operating systems than do PLCs, and because the desktop computer hardware is typically not designed to the same levels of tolerance to temperature, humidity, vibration, and longevity as the processors used in PLCs. 12. List different components of industrial robot. State functions of any two. For MEMS, components of robots. A robot is a complex machine which may contain mechanical, electrical, pneumatic, hydraulic, and microelectronic components. Essentially, a robot consists of 4 elements. Drive system. The drive system controls and velocity of end effectors. There are 3 major types of drive used in robots, namely electrical drives, hydraulic drives, pneumatic drives. Control system. The control system controls and velocity of the end effectors of the robot based on the logical sequence and operating programs. Measuring system. A measurement of output is important. The control system continuously measures the actual position during a motion cycle and compares it with the theoretical values required in order to provide a correction action. Sensors. The main function of to permit the robot to interact with the environment in an intelligent manner. Various types of sensors are available nowadays, including tactile proximity, ultrasonic ranging, and vision sensors. 13. List advantages and disadvantages of MEMS. 4M. ANS. Advantages. 1. Batch fabrication, and hence reduced cost. 2. Reduced size and reduced power, due to pin size and reduced package volume. 3. High precision and resolution. 4. Reduced parasitic due to interconnecting devices. Disadvantages. 1. Very small to trace out. 2. Due to small size, it is physically impossible for MEMS to transfer any significant power. 3. They are made from poly-Si, a brittle material. They cannot be loaded with large forces, because brittle materials can be fractured easily under high stress. 14. draw construction of Cartesian and cylindrical robots, and explain briefly their degree of freedoms. ANS divided by